All right. Um, so with rational functions, just like we have with numbers, when we were in grade school, we learned how to add, subtract, and then maybe a little bit later, we learned how to multiply and divide. But in rational function land, we actually did multiplication and division first. And then now we are moving to adding and subtracting. And adding and subtracting is a little bit more involved than multiplying and dividing because you have to find this thing called the least common denominator. And I'm going to show you some numerical examples to kind of talk about the importance of this without any algebra at all. And then we're going to move towards creating least common denominators in those more algebraic type of situation. So your goal is to get the same denominator in both fractions, and then you can add or subtract across in the numerator. Example one here, we're actually not going to do algebra yet, but I'm just going to kind of show you a little bit of some fraction math and where this stuff is coming from. So we can only add across when there is a common denominator. So in this type of problem, we have 16 for our denominator, so we're good. And then we can do 9 plus 3, which is 12. And then I can simplify this fraction to 3 over 4, because 4 goes into both 12 and 16. In this level of problem, we don't have the same denominator. So what you don't want to do is just add across. So don't do this. Heck, I don't even know what to put in the denominator there. Well, I mean, some people might be tempted to just do that. Don't do that. Bad. So what you do want to do in this type of problem is get that common denominator. And one thing that I notice here, and I'm just going to kind of do this in different colors, is that I have a 11 and a 3. So maybe if I have a 3 from the other fraction, and in this fraction, I mean 3, I need an 11 to get that common denominator. And if I multiply the top and the bottom, if I multiply the bottom, I also have to multiply by the top, the same thing. So you can kind of see that step, and that's the most important step. We get, as a result, 22 over 33 plus 3 over 33. So that's going to get us to 25 over 33. So on Delta Math, we are going to kind of assign you those numerical ones just to kind of build the concept of the least common denominator a little bit. And by the way, when we say least common denominator, we say that it is 3 times 11, which is 33. So some people actually like to write their least common denominator before they even think about creating that common denominator type of fraction. All right, so now we're going to go to the algebra level. So some of the problems that you're going to see on Delta Math, if you are lucky, are ones that have the same denominator already. So we already have the least common denominator on this. So what we do is we just keep the denominator the same. And then we do 5 minus a negative 6. And then this would just be equal to 11 over 5x plus minus 1. And that's your final answer. So that's kind of the intro to algebra level 1. So note, the denominators don't change after you find the LCD, because they are a common denominator. All right, now this one, here's one thing that I noticed here. I noticed that a 3 goes into a 6. So I'm thinking, and I also have an X. So I have an X in both denominators. And I also can get to a 6. So I can actually get a common denominator by doing that. So if I just multiply by 2, I'll actually have a 6x for my common denominator. So it's going to be 16 over 6x plus 5 over 6x. And the 6x stays as the common denominator. And then 16 plus 5 is equal to 21. And that's our final answer. All right, now we're going to go to the full-blown Algebra 2 level. I would say for the LCDs, you want to make sure factorable expressions are factored. And we're going to talk about that right now for why that needs to be. So I'm going to write 5x plus 1 over x minus 6. And then when I factor the x squared stuff, I know that I have an x times an x. And I'm going to bet you that there's going to be a 6, since we already have an x minus 6. And 6 times 4 is equal to 24. And I need this to be able to subtract to a negative 10. And what I notice here is on this fraction, I have an x minus 6. And then on the fraction on the left, I have both an x minus 6 and an x minus 4. So I'm going to need a x minus 4 and a x minus 6. So in order to do that, I'm going to get an x minus 4 and a x minus 4. So I already got the denominator. And just to kind of save a little space, I'm going to have a little space for my numerator as well. And this is nice on kind of those longer examples. So my numerator is going to be x minus 4 times 5x plus 1. And you're going to see, why we want to have this nice space minus x. And when we do that, we need to make sure that we multiply. So I have 5x squared plus x minus 20x minus 4 minus x. And what happens is that the x's go away and the minus x. So I'm just left with a 5x squared minus 20x minus 4. And that's my numerator. So then my answer is my numerator over my LCD. So that's going to be the 5x squared minus 20x minus 4. And then that's going to be over my least common denominator, which I had in blue. And that's going to be the x minus 4 times x minus 6. And we are completely done. So I would say on this scale, on your mastery, we will have maybe one example that's going to not have like factoring, just to see if you kind of got the common denominator concept, and then maybe a level like this as well, just to make sure we can combine like factoring and stuff with this. All right, another variation of the Algebra 2 level is a situation where you have entirely different denominators. So if the denominators are entirely different, the two denominators multiplied is your LCD. So what I mean by that, and I'll just kind of use blue again here to kind of raise the point. What I mean by that is that your LCD would be x minus 3 times x minus 5. And when I'm doing this, let's see, I got the x minus 3 on this one. So I need an x minus 5. And then on this, and I like to put parentheses so that way you can kind of remember that you need to distribute. And then on this one, I have an x minus 5, but I don't have an x minus 3. So my LCD is good. Now I'm going to kind of figure out what the numerator is. So I got the denominator. So then the numerator, all we need to do is we need to do the x minus 5 times 3 minus a 3x times x minus 3. So that's going to be a 3x minus 15 minus 3x squared. And then don't forget to distribute the negative with the negative. So that's going to be a plus 9x. So I'm going to have a negative 3x squared. Now I get to kind of be in standard form. 3x plus 9x is going to be 12x minus 15. And then my answer is simply our numerator over our LCD. And we could just keep it in standard form on the top. And then on the bottom, we could just write out our LCD. So our LCD is going to be x minus 5 times x minus 3. And then we are considered to be all done. So more of a story, you want to think really hard and clear about what your LCD is going to be. If in doubt, just let me know. I can take a look at your example in a breakout room. But once when your LCD is created, you are good with the denominator. Then you just need to focus on the numerator. And then your final answer is just numerator over denominator.